In this next module, we're picking up where we left off in the last chapter, the last module, excuse me. We were doing all kinds of different transformations. We were rotating things, we were reflecting things, we were translating things. And so now in this module, we're starting by doing sequences of transformations. So in the explore activity that your text describes, in part A, you see it says, using geometry software, draw a triangle and label the vertices A, B, and C, which you see that I've done here. Then draw a point outside of the triangle and label it P. It says, rotate triangle ABC 30 degrees around point P. Okay, so in order to do that, I have to tell the program that I want P to be the center of my rotation. And then I'm going to take this figure and rotate it, but I don't want it around that angle by 90 degrees. I wanted 30, and there's my rotation. And it says label that image as A prime, B prime, and C prime, and when I tell the program to label my points, it automatically calls them that. Then it says rotate this triangle now by 45 degrees around point P. Okay, so I'm going to tell it that that's my center again. And I'm going to rotate this, but not that or that. And I'm going to rotate it, like the activity said, by 45 degrees. And your text says to label that image as A double prime, B double prime, C double prime. And look at that. Program knows already what I want those points to be called. And then in part B, it says to make a conjecture regarding a single rotation that will map triangle ABC to triangle A double prime, B double prime, C double prime. So what I'd hope you'd kind of have a gut instinct about is that if I had started at triangle ABC and done a different rotation, I would land at A double prime, B double prime, C double prime. So let's test that. Let's take this triangle and rotate it by, well, my first angle was 30 degrees, my second angle was 45 degrees. So if I add those two things together, then where does it land? Well, notice that it's highlighted this again. Well, that's because it landed there once again. So what we just noticed is that rotating triangle ABC 75 degrees maps it to triangle A double prime, B double prime, C double prime. And we did that. In part C of that explore activity, your book says using geometry software, draw a triangle and label the vertices D, E, and F. So I need to open a new sketch and make a new triangle this time. Okay, so I've made my points. Now I connect the dots. There's triangle DEF. It's asking me to draw two intersecting lines and label them J and K. fix that. Okay, so here's a line, and there's a line. And J and K are their names. It says reflect triangle DEF across line J, and then reflect that image across line K. Okay, so in order to do that, I have to tell the program to mark the mirror. So I'm telling the program this is my line of reflection, and I'm taking this triangle and I'm reflecting it. Okay, so now it's over here, and my program is very nice to me. It knows exactly how I want it to label the triangle. And now I'm going to reflect this over line K. So now I need to tell the program that K is my mirror. And I'm going to reflect this triangle over that line. And it's D double prime, E double prime, F double prime. And now finally, it's asking us to notice a relationship between triangle DEF and triangle D double prime, E double prime, F double prime. Okay, so in the last example where they wanted me to make a conjecture or an educated guess about what happened, I had done 2 rotations, and I conjectured that if I did a rotation of the sum of those angles, I would land in the same place. So this time I did 2 reflections, and I'm trying to think of one transformation that would have the same result. So one thing that I'd like you to notice is, remember that way back in Module 1 when we talked about how to look at a figure and determine whether it's been reflected or something else, is if the orientation of the graph has been changed. Meaning, for example, in this triangle, if I'm going counterclockwise, starting at D, it's D, E, F. Now, if I go to my double prime triangle and I start at D and I'm going counterclockwise again, it's D double prime, E double prime, F double prime. So since that order didn't change from this triangle, DEF, to this triangle, my double prime triangle, that's not a reflection. Well, it's not a translation either, so let us consider a rotation. But around what angle? Let's make some educated guesses. Maybe if I take this triangle and I rotate it around this point using this angle measure, it'll land here. Okay, well, first let's measure that angle. So X, Y, Z. And when I take this triangle and I rotate it, that angle, oh, that doesn't work. So I'm not even going to finish that rotation. Let's measure this angle. And try to rotate this triangle around that angle. And oh, that's definitely not it. Okay, so I've exhausted some of my educated guesses so far. So let's go back to what we did in the last module. In the last module, we connected a point to the center of the rotation, and then we connected the image of that point to the center of that rotation, and then we measured the angle. Okay, so let's measure that angle. So my actual angle of rotation is 116.41. Well, there's got to be some relationship between the angles, the angle formed by the intersecting lines, and this angle of rotation. So I wonder if I use my calculator I have a hunch that if I double this angle, well, hey, look at that. Okay, so now if I do the rotation on that angle, notice how it pops back up at this triangle. So that's my conjecture. So the single transformation that would map triangle DEF to triangle D double prime E double prime F double prime is rotating triangle ABC an angle twice the measure of the intersecting lines maps it to triangle A double prime, B double prime, C double prime. And that's what we did. And then in your book, it has 2 reflect questions that kind of ask the exact same thing that we just observed. In part B, we observed that if we add the 2 angles of rotation, we can get the 1 angle of rotation that will map triangle ABC to A double prime, B double prime, C double prime. In question 2, it's asking you in general, what do you do when you're reflecting something over 2 intersecting lines? The one transformation that's equivalent to that would be a rotation of an angle measure that is twice the angle formed by the intersecting lines. So now in this discussion this discussion question, it says repeat step C, but make the lines parallel instead of intersecting. All right, so let's come back here. And I'm going to get rid of this triangle. And I've got a few extra things that I don't need, so let me get rid of them. And I want a line that's parallel to J this time. So I'm going to tell my program to construct through this line, through this point, and parallel to this line, construct a parallel line. So now I've got parallel lines, okay? So when I'm going to call this line K. When I reflect this triangle over line J, it lands here. And I'm going to take that triangle and reflect it over this line. And now it's here. And this is E double prime, D double prime, F double prime. So I started with reflections, so it'd probably be a good idea to make sure that this isn't a reflection. So remember our test, if I take this triangle and I name the vertices going counterclockwise starting at D, it's D, E, F. If I start at this triangle and go counterclockwise starting from D, it's still D double prime, E double prime, F double prime. So it is definitely not a reflection, and it looks like it's kind of facing the same way as this triangle, so it looks like it's a transformation. So we think about transformations in terms of direction and distance. So let's consider the line connecting F prime to F, or the segment connecting them. So let's draw that segment and see if there's anything interesting about that segment and my parallel lines. Well, it looks like I might have a very special kind of angle here. Let's check. If I measure this angle, it's 90 degrees. So that means that it traveled in a direction perpendicular to my parallel lines. Okay, well, how far did it travel? So let's find the length of F to F prime. And, how far away are these two parallel lines? Does my program have a nice, nope, it doesn't have a nice way to measure the distance between two lines, but the distance between them would be a perpendicular segment, so I'm just going to draw a perpendicular line and then measure the length of this segment and then find its length. Well, they're not the same, but once again, I'd hope that you'd notice, oh, there's an interesting relationship going on here. The triangle traveled a distance that is twice the distance between the two parallel lines. Okay, so make a conjecture about what single transformation will now map triangle DEF to D double prime, E double prime, F double prime. And it's going to be a translation. Try translating the triangle twice the distance, excuse me, between the parallel lines in a direction perpendicular to the lines. And that will map triangle DEF to triangle D double prime, E double prime, F double prime. So in example 1, part A, as usual, there's an example where they're going through the process and showing you what they did. So in this part A example, they're doing a reflection over line L and then translating it along the vector V. So they took the triangle ABC and reflected it, and it landed here at A prime, B prime, C prime. And then the next step was to take that triangle and translate it along the vector that was given to you, vector V. So notice how I could take this vector and that's how far B is from B prime, and A is from A prime, and C is from C prime. So that's what they did. In this example, we're being asked to do a rotation, then a translation, and then a reflection. And I wanted to make sure to do this hands-on in this video because there's no coordinates in this diagram. There's no numbers. So it's a little bit different than doing it in examples that I've shown you in the past. So let me make this a little brighter. Okay, in order to apply the rotation, I'm taking this triangle and rotating around this point. But I mentioned earlier I don't have any coordinates. So let's make some. Since P is my center of rotation, I'm going to treat that point P as if it is 0, 0. You're allowed to do that. And what I'm going to do is, since the problem says to rotate this 180 degrees, remember that I showed you that one of the ways that you can do a rotation is to actually physically pick up your paper and turn it 180 degrees. So I turned it 180 degrees. And now it looks like this. And if I think of this as having an XY axis now, and I flip it upside down and I try to consider what the coordinates of A, B, and C are now, well, then A prime would now be at -1, 2. B prime would be at 1, 1, 2, 3. And C prime would be at 1, comma 0. Okay, so if I'm considering point P as the origin, this is where these points would lie with respect to that origin. So now let's bring it back to what it normally looked like. And let's take these points and plot them on this grid that actually doesn't have any numbers, but we're treating it as if this is a y-axis and this is an x-axis. So we're treating it as if P is the origin. So -1, comma 2. This is where the point A prime would be. 1, comma 3. This is where the point B prime would be. And 1, comma 0. This is where the point C prime would be. So hopefully this is a strategy that you can use yourself if you're ever asked in the coordinate grid to do a rotation around a point that isn't the origin. Just draw a pair of axes through that point, treat it like the origin, spin the paper around, figure out where the points are with respect to that not quite origin, bring it back to normal, plot the points where they would apply to that origin, and then identify their actual points. Okay, so now that's my A prime, B prime, C prime. And now I have to do a translation along this vector. So I want to take this vector and translate each of these points along that vector. Well, some of you might still be in the habit of taking this vector and physically copying it, and copying it. But in this example, let's go ahead and just count the spaces. So 1, 2, 3, 4, 5 to the right, and up 1. Okay, so from here, 5 to the right, and up 1. Here is C double prime. 1, 2, 3, 4, 5, and up 1. There's B double prime. Finally, A prime. 1, 2, 3, 4, 5, and up 1. There is A double prime. And then finally, I'm going to take this triangle and reflect it over this line. So since C is one space above it, since C double prime is one space above it, C triple prime will be one space below it. B double prime is 1, 2, 3, 4 spaces above it, so B double prime will be 1, 2, 3, 4 spaces below it. Here's A double prime. It is 1, 2, 3 spaces above. So 1, 2, 3 spaces below. There is A triple prime.